Hello students, good morning. So this is now surface areas and volume part 2. In our last video, we saw surface areas and volumes of plane figures. Today we are going to concentrate on surface area and volumes of 3D figures, which means 3-dimensional figures. So what's the difference between a 3D figure and a plane figure? A plane figure is something that you can draw upon the plain paper and you can just see one side of it, while 3-dimensional figure is a figure which has 3 dimensions, that is 3 different, on all the sides it has a shape. For example, if you consider an example of a cube, a dice, a small dice that you play with is a shape of a cube. So if you just turn around all sides, you can find that it is made up of 6 squares. What I have drawn here is a cuboid. A cuboid is made up of rectangles on all the sides. Hence, there are 3 dimensions of it: length, breadth and height. And the letter alphabet D that I have written here denotes diagonal. Okay, it's the line connecting the 2 ends of the cuboid. Okay. A best example that you can quote for cuboid in your day-to-day life is a matchbox. You can just take a matchbox and see, and it's again your maths textbook. Even your maths textbook is in the form of a cuboid. So now if you look at the cuboid, total surface area is given by the formula 2 into LB plus BH plus HL. So you know that when you take a single surface and when you consider it as a rectangle, you know that area of the rectangle is given by the formula L into B. Since it is to be found out from all the sides and it has 6 faces, we give the total surface area formula by formula 2 into LB plus BH plus HL square units. Next we have lateral surface area or curved surface area, which means the surface area excluding the top and bottom. An easy way to remember is excluding the top and the bottom. When you find out the area, we call it as curved surface area or lateral surface area. It is given by the formula 2 into L plus B into H, where L stands for length, B for breadth and H for height. Next, if you want to find out diagonal of a cuboid, we have a direct formula where it is given by square root of L square plus B square plus H square units. Now length of all 12 edges. So you know that there are 12 edges of a cuboid. So length of all 12 edges is given by the formula 4 into L plus B plus H units. And finally the volume. Volume of a cuboid is given by the formula length into breadth into height cubic units. Next, let's move on to the next shape, which is called a cube. So as I told you, the playing dice that you use is an example for a cube. A cube is made up of squares on all sides. Hence, all the sides of a cube will be equal. If we take it as A, total surface area of a cube is given by the formula 6A square units. Curved surface area or lateral surface area is given by 4A square units. Diagonal of a cube is given by root 3 into A units. So it's here we have only units because it is either given in centimeters or in meters. So for area, we write the answer in square units. For volume, we write the answer in cubic units, while for diagonal and other things we just use units. So here length of 12 edges is given by the formula 12 into A. So in this case it is 12A, that is 12 into sides. Length of the side. Volume is equal to A cube cubic units, where A stands for side of the square. And area of 4 walls. So this is a very common question in surface area and volumes. They'll ask you to find out the cost of whitewashing 4 walls of a room, or how to lay tiles on the floor of a room. For all that we need area and surface area volume. So here, area of 4 walls, we have a direct formula which is given by 2 into L plus B into H. Actually, this is the curved surface area of a cuboid, and same thing is used for the wall, 4 walls. Moving on to cylinder. So a cylinder, you can just make it by rolling out a paper. Just take a piece of paper and just fold it breadthwise. Along the breadth, you just fold it and you will get a cylinder, a cylindrical shape. When the four corners are joined together, you get a cylinder. That's called a open-end cylinder or a hollow cylinder. The water bottle that you use, in general, just if you cut down the cap, what you get is a cylinder again. So you can see the diagram drawn here. If you take a cylinder, you have two circles on the top and the bottom, and the radius, so since it is circle, you have radius and the height. The perpendicular height is given by the word h. Considering cylinder, the lateral surface area of a cylinder is given by the formula 2 pi RH square units, where pi stands for a constant called its name as pi, and its value goes as 22/7 or 3.14 centimeter in terms of decimal. R stands for radius and H for height. The base surface area, as you can see, the base and the top both are made up of circle. So base surface area is nothing but area of a circle, which is given by pi r square units. Total surface area is given by 2 pi r into h plus r. So this is actually derived by doing 2 pi r h plus 2 pi r square. So when we combine both, we get it as total surface area. And then moving on to hollow cylinder. So hollow cylinder, you can see on the right hand side a cylinder, a cylindrical shape you have. It's hollow because there is nothing inside, it's open ended. In such a case, we have curved surface area given by the formula 2 pi h into r plus h. It is the same as the above. So here we had 2 pi r h, here also 2 pi h into r plus r. So this r stands for outer radius, small r for inner radius. Base surface area again pi r square, but one change, that is pi into radius of the outer circle minus inner circle. And total surface area is given by 2 pi into r plus r into h plus r minus r square units. Okay, it's a continuation of surface area and volumes of three-dimensional figure, students. Now we are moving on to right circular cone. You can see the picture given here. This is a right circular cone, which is a small triangle mounted over a circle. So you can imagine a joker cap or a birthday cap, for example. So you can see that you have a square at the bottom and on the top it's a triangle. So when we have it like this, you have the height as h, r as the radius, and L, the letter L what I have written here is called the slant height. It's a slanting height. So when you have it like this, your curved surface area of a right circular cone is given by the formula pi r L, where r stands for radius and L for slant height, so many square units. Similarly, TSA or total surface area is given by pi r into L plus r square units. So you know that curved surface area is only pi r L and total surface area is pi r square. When we combine them both, we get total surface area. And volume of a right circular cone is given by 1/3 into pi r square h cubic units. Since its volume, we have to take it as cubic units. Now moving on to sphere. So first let's understand the difference between a circle and a sphere. A circle is a plane figure, while sphere is a three-dimensional figure. That means you can just visualize. For example, if you just draw a circle on a plane figure, on a plane paper, we just call it a circle. But when you just play with a ball, and if you consider that ball to be transparent, you can see it is it looks circular on all sides. That's called a sphere. Now you can see the picture on the right hand side. You have a center called O, suppose I name it as O, and a radius R. So when you have it like this, your surface area is given by the formula 4 pi r square units. You have to remember that area of a circle in general is given as pi r square, while it is on all four sides it's made up of circles, so we get the answer as 4 pi r square. Curved surface area of a hemisphere. The word hemisphere is half of a sphere. So you can see actually when you have a circle, half of it is called as semicircle, but when you have a sphere, half of it we call as hemisphere. The picture on the right is an example of a hemisphere. Since it's drawn on plane figure, I couldn't show you as a 3-dimensional figure. You can imagine, students. So it's called CSA of a hemisphere, curved surface area or lateral surface area. It's given by 2 pi r square. It's simply done by dividing the area of a surface area of a sphere by 2. Similarly, total surface area of a hemisphere is given by 3 pi r square. It's simply by adding 2 pi r square plus pi r square. Volume. So volume of a sphere is given by 4 by 3 pi r cube cubic units. Volume of a hemisphere, half of it, that is 2 by 3 pi r cube cubic units. And volume of spherical shell with outer and inner radius, just like a hollow cylinder. When we have a hollow sphere made up of inner radius and outer radius, we have volume is equal to 4 by 3 pi into r cube minus r cube cubic units. So that's all, children. All these what we saw today are all surface area and volumes of 3-dimensional